Yes, class. Am I audible now to all of you? Please check and inform, just confirm.
Yes, ma'am.
Okay. So we had started with laws of motion in the last class, and we were saying that basically in this chapter, we will see the cause of kinematics or all the kinetics that we have studied. So basically, this chapter is all about forces. So we have not been introduced to force yet, right? Till yesterday's class, we had seen the concept of inertia and we had seen the first law. So basically, there's no difference between the definition of inertia and the Newton's first law. That's why we say Newton's first law is law of inertia only. So what was the definition of Newton's first law? See, one thing that it introduced as the concept of force. And secondly, body will maintain its inertia unless an external force is applied on the body. This is all the gist of it. And you should be aware about the definition of inertia. And please again keep it in your mind. I have repeated yesterday also several times. I am repeating it today also that inertia is not a force. If your body is moving forward because you were in a state of rest, that is the property of your body. That is called as inertia. That property of the body to maintain its state is known as inertia. Inertia is not an external force or an internal force which is coming. So please do not confuse this. Many students confuse inertia and take it as a force. Inertia is just a property. It's like a characteristic you have given it. Okay, so types of inertia we have done. Newton's second law we couldn't, right? Okay, momentum also we had started momentum. Momentum is what? Momentum is basically the amount of motion left in a body. If you are running, you have seen in marathon, especially when the finish line is there, marathon runners or athletes who are running, even after crossing the finishing line of the race, they cannot stop themselves immediately, right? Reason is that because they have gained so much of momentum, so much of amount of motion in them is so much that they are unable to stop immediately. That's the reason you see athletes are able to run a little more distance than the prescribed distance, right? So that is what is meant by momentum. So this is also what we have discussed yesterday. We discussed the formula. Formula of momentum is product of mass into velocity. Velocity is a vector, mass is a scalar, but momentum is a vector. All right, so this we have discussed it. Okay, Newton's second law. Let's straight away start with Newton's second law. So in Newton's first law, we had discussed yesterday that if an external force is not being applied, the inertia state is not changed, right? Now, this external force, now we'll be discussing about this external force which is acting on the body. I hope you understand what is internal force, what is an external force. If I am talking about a system means the place, the part of the universe which is under consideration, under observation. Like if I'm just talking about a pen, all the forces which are acting on the pen, every force which is acting, FBD also we'll draw, the free body diagram of the pen, everything. So this is my system right now. Now, anything which is present apart from this pen in this universe will be my surrounding. So system and surrounding make our universe. All right. Now this pen is only under my consideration, right? So if due to contact, this is having a normal reaction upwards. Due to gravity, mg weight will act downwards. So these forces are internal forces because they are part of the system. And my system right now is this pen. And suppose there is an external force. Suppose I am only, my muscular force is the external force, which is tilting this. So this becomes external because my muscular forces or my hand, this was not a part of the system, right? So you should understand what is system, what is surrounding, and then accordingly internal and external forces. So yes, coming back to our topic. So we were discussing now this external force which is present, which is shifting the body's state of motion, state of rest, or state of direction, whatever is the direction. This external force, now we'll be talking about this. So basically, Newton's second law of motion is in relation to measure the force. Now, delta P means change in the momentum, T means the change in the time. So the Newton's second law basically says that this external forces rate of change of momentum, dp over dt. Now one more thing, class. Whenever I say rate of something, rate means something which is changing with respect to time, right? Like we say rate of change of velocity is acceleration, means within a period of time velocity is changing. If velocity is constant, we get no acceleration, right? Or we say rate of change of displacement is velocity. It means in a particular time duration, displacement is being changed, right? So similarly, rate of change of momentum means momentum which is changing with respect to time. At t is equal to 0, suppose I have 5 kg meter per second square. At t is equal to 10, I have 10 meter per second square. So this is the difference which is coming. Now, when I take final minus initial, it will give me the change, right? So when I say the term rate, it means the change in time. All right. So F external is dp over dt. Now, class, one more thing. This external force which we are referring, dp over dt, one thing I'll tell you here. dp is the change in momentum, and dt is the change. Ali Mohammed, you're entering from another ID. Change in time. So change in momentum, change in time. This is our external force. Now, before that, let me just give you one more example about that system and surrounding thing that is important. Suppose this is a glass of water. All right. I have kept it on a table. Now this table plus glass, 1, 2, 1 plus 2. This is now my system. Now any other thing which is present apart from this glass and table in this universe is my surrounding. So basically the universe is made up of the system and the surrounding. I'm repeating this. All those who have missed, all those who have not understood, please hear again properly. So this is now my system. Suppose if this glass is kept on this table, so definitely gravitational force mg will act downwards and normal reaction will act upwards. And let's say there is one more block kept away from this, and this is also on some contact surface, so it also has normal reaction. Now this normal reaction, this mg, these are part of the system, so we say these are what? These are the internal forces. And this normal reaction, which is formed or due to the contact of another box outside, this is now acting as the external force. All right. Now, if this net force is 0 here within the system, we say the system is isolated. So you will witness this question a lot. An isolated system has this, and all. So this term is often used in the questions, especially from laws of motion. All right. So isolated system means net forces. Basically, equilibrium has been achieved, whether it's translational equilibrium, rotational equilibrium. But see, you won't get rotational equilibrium in this chapter at least. That will come after we study rotation. All right. So after this, we have work energy and power. Then we have rotation. That time we'll discuss about the rotational equilibrium. Right now, you should just focus that if isolated system word is coming in the numericals, in the questions, in the conceptual question, it simply means that net force is 0. All right. Now, one more thing, class. Forces are also of two types when you are using it. One is the average force, another is the instantaneous force. Now, if I say a body has started moving, and if I have started the timer, the initial time that was t is equal to 0. After a while, when I stop the timer, time is 10. So what is the 0 to 10? This is the duration. 0 to 10 seconds is the duration, right? So 0 to 10 seconds, this is the duration. In duration, we use average. And in average, you write delta P by delta T. All right, this is delta P by delta T. Instantaneous means exactly at a time instant when you use. All right, exactly at a time instant when you use the formula, and exactly at a time like 0.01 seconds, 0.3 seconds, then you use this differentiation formula, dp over dt. All right. Now, so this is clear what all things we have discussed, that this external force is rate of change of momentum. Now, just a second. All right, now the what was the formula of momentum? Yes, Abir,
Mass into velocity.
mass into velocity. Very good. So momentum is mass into velocity. So we can put instead of P, mass into velocity over dt. Now see, mass is a constant term, right? You won't get variable mass. See, variable mass is there, but in your syllabus, even in class 12, you don't have variable mass. You have constant mass. So what we'll do in differentiation, when you differentiate, the constant term comes out. So mass will come out and we are left with dv over dt. Yes, Alina Aftab, what is this dv over dt? Can you recall it? dv over dt.
Differentiation.
What, Alina?
Something related to differentiation.
Yeah, dv over dt. Whose formula is this? I have repeated also in today's class. dv over dt, v over t, velocity by time. Yes, Alina. Ali, Ali Mohammed.
Yes, ma'am.
Yes, Ali. What is this dv over dt? Yes, Ali. Answer. Anyone else? What is this dv over dt? Whose formula is this? When do we write this? Anyone? Yes, Abhi.
Ma'am, for instantaneous velocity.
Velocity is there in the formula. Velocity by time. Whose formula is this? Velocity by time. Acceleration, right? Acceleration. So dv over dt is acceleration. So we can replace m dv over dt as m into a. This is the formula. Force is equal to mass into acceleration. A is acceleration, m is the mass, F is the force. and it's a vector quantity. Definitely force is a vector quantity. SI unit is Newton and CGS unit is dyne. And how do you convert SI into CGS? 1 Newton is equal to 10 to the power 5 dyne. All right. So start writing from here. If you have anything to ask, please let me know in the chat column. Yes, so it starts from rest and attains a velocity of 10 meter per second in 5 seconds. You have to find out the force. Now, mass is 5 kg, velocity is 10 meter per second, and time is equal to 5 seconds. So, force is change in momentum. What is momentum? Mass into velocity by time. So, yes, 10 Newton answer is right. Now, the next question, a scooter is moving. Okay, those who have not written, write it quickly. Write down the next question. Yes, class. So this is a scooterist moving with a speed of 36 kilometer per hour, sees a child standing in the middle of the road. Firstly, the speed is given in kilometer per hour. So our first step is that we have to convert it into meter per second. So speed, which is 36 kilometer per hour, best trick to convert it into meter per second is just multiplied by 5 by 18. 18 1, 18 2, 5 into 2 is 10. So 10 meter per second is the speed now that we'll be using. Fine. Now it says that he applies the brakes and brings the scooter to rest in 5 seconds. So this is our initial velocity. If the scooter has and brings the scooter to rest, yeah. So if the scooter is at rest now after this, so final velocity will be 0. Time here is 5 seconds. Average retarding force we have to calculate, where the mass of the driver is. Mass of the driver plus vehicle is given as 300 kg. Minus 600 Newton, Abir. Okay, Abir, let's check your answer. See, we need acceleration first. We have the mass, we want the force, we need the acceleration. For acceleration, we have the initial, final velocity and the time. So let us use it. V is equal to U plus 80. Let's use our first equation. V is 0, U is 10. plus 5a. Yes, answer will be negative. 5a is equal to minus 10. Acceleration is equal to minus 2 meter per second square. Correct, Abhi. Mass is 300 kg. F is equal to ma you are going to use. So force is equal to 300 into minus 2. So force is minus 600 Newton. Correct. And force is a vector quantity. So we can get our answer as negative. Write it. Then I'll discuss the Newton's third law. Yes, class, let's come to the third law. So this third law is very easy. This is just based upon action and reaction forces. So if two objects are placed together, and even if this is just an example, we will discuss applications later. So suppose this is block A, this is block B as shown in the figure. Block A is exerting forces on block B, right? F, A, B. So block B will also be exerting force on block A, F, B, A, right? And both of these forces in opposite direction. So we can say FAB is equal to minus of FB. Fine. So basically this says that to every action, there is an equal and opposite reaction. This is the Newton's third law. So they are instantaneous, means if action has occurred at one point, so the reaction will occur immediately. You won't have a time lag for 1 hour, 2 hour, some days or like that. Immediately you have the reaction present. All right. So action and reaction are instantaneous. Now, when a person walks, this is a little different. First, you Okay, if completed. Now, this Newton's third law is almost over. This walking example we'll just discuss in the next class. Then impulse is there. So this topic will be over. Impulse, this and pulley mass that I'll do in the next class. All right. So laws of motion will be completed on time this time. Then we'll start with work, energy, and power. And Alina, please update me with the team. You have not texted them. Whatever is the time issue, whatever is your personal
Ma'am,
purpose.
I decided to my talk to my parents.
Mm-hmm.
So I told them that ma'am said that in the other class the work energy theorem is chapter is about to be over. So she was like, in that case, you continue with this class. We'll see later.
Okay,
She
let
said
us
like,
see. If I think most probably it will become parallel. When the syllabus become parallel, no, as soon as it will become parallel, I'll inform you. So you can
okay,
switch
ma'am.
the batch. Okay, I think it won't take time
Okay.
because we are also here heading fast only because we also want the syllabus to be completed. When your schools will reopen, I think most probably in the first week of September, your schools are reopening, right?
Ma'am, mine is already open.
Your Okay, Alina. Okay, yeah, 11th August you have the exam. No? Okay, fine then. So, Alina, regarding that also, your exam also, please let me know by the next week. Okay, because that will be the last week before your exam. Okay. So, if you want extra classes, any doubts in any portion from both the chapters, motion in a plane and motion in a straight line are coming. No. So just update me, let me know. Okay, Alina.